Lina. As Lina mentioned, I'm a scientist with CSIRO, but my training is in the psychological sciences. So I try and understand why people do the things they do and why they behave in the ways that they do, the decisions they make, and how we can potentially change behaviour if we need to. So the topic of my conversation today is really to cover this broad concept of social risk. And I'm going to talk about it with respect to synthetic biology in a very broad context, and then focus on a more application-based social risk assessment that we're currently doing in the context of Carp biocontrol. So both of these examples have a lot of parallels in terms of the social risk elements and the potential application of novel technology in culturally significant regions. So whether it's carp control in the Murray-Darling Basin area, or whether it's implementing novel technologies in the Reef. I wanted to start by defining social risk because with a technical audience it's probably not as clear what social risk might entail. So risk concepts in general share a common element that there is some distinction between reality and possibility, and there is a cause and effect connection and potentially undesirable effects that could be mitigated. But for social risk, it kind of broadens that understanding and considers the likelihood of undesirable effects in the context of our socially constructed reality. So social risks are not substantive risks, they really are reflective of what people think, how they see their world through their own eyes. So I'll give you an example. This is an environmental risk assessment that I just got off YouTube. So you can see that there's a problem that's been identified. There are some inputs to identify the hazards, so things like air pollution, toxic chemicals, pesticides, whatever. So there's some hazards, then there's an exposure component, and you calculate some level of risk characterisation. In a social risk assessment, we have a lot more subjective data that we're playing with. So in a social risk assessment, we look at attitudes or beliefs that people have about whether it be a technology or an event, the value sets that people live by. So these are beliefs about how the world should be, your cultural values, your family values, social norms that you live under. And so that really is reflective of who your social group is, how people in that social group behave, what they consider is right and wrong. And that's kind of associated with the ethical and moral approaches as well, which Lucy Carter, my colleague, will cover a bit more tomorrow. And emotions. Emotions play a really significant role when you're talking about social risk, because we have a social reaction or an emotional reaction to information, particularly new information, that challenges the way that we understand the world. And then there's, of course, knowledge and trust. And that can be individual level, or it can be interpersonal trust, institutional trust. And so those characteristics in the circles represent individual level factors, but then they also exist within a broader social context. And that will be like a level, group level kind of information. And so that can be economic impacts that are perceived to be relevant when you're talking about a novel technology. So other social impacts on communities, whether it affects different subpopulations, governance, infrastructure. And then all of that information is combined to determine what hazards might exist in a social context. And then we come up with an idea of what predicts social risk and what might be the mitigating factors. So this is just an example of how risks can be perceived and how emotion plays a role in our perception of risk. So this is a kind of classic example about the way people think versus what the reality is in terms of hard data. So in the big orange circle, or red circle, you can see that the public risk of terrorist attacks is pretty high, especially if you're talking about the US. But in reality, or the actual possibility of that hazard is quite low. Similarly, if you look at the blue circles on the far right, the actual hazard of a traffic accident is quite high relative to the riskiness we perceive it to be. So we take our cars every day to do a number of different things, and we don't think twice. And that's because of our lifestyle preferences and the things that we're used to doing. So that was just an intro on social risk. So now I'll focus a bit more on synthetic biology, and I'm sure most people in this audience are familiar with this topic. But for those of you who aren't, it's a new area of genetic science that's rapidly developing, and it's an area of research that CSIRO is investing quite heavily in, not just in terms of the research being developed, but also focusing on capability development in Australia. And so with this new technology, there are a lot of anticipated benefits, but also very high social impacts potentially. So synthetic biology in Australia will cover technical solutions or advancements in a number of different areas, and that can be from biosecurity or pest management all the way to health and the chemicals or materials that we might use on a day-to-day basis. In terms of what the public knows about synthetic biology, not much at all. It's a relatively new concept, and because it's so new, there's no real public understanding or a research understanding of what the public thinks about it. So that's part of my team's role, is to really establish a baseline understanding of what the public thinks of synthetic biology and the potential issues that may arise because of it. But we do know that the public is aware of biotechnology and development in biotechnology. They just don't know very much about what that means. But, as social scientists always say, knowledge isn't always a prerequisite to form an opinion. So often physical scientists think that, if I just explain it to them in a different way, if I just give them the numbers, they'll understand what I mean. But unfortunately, that's not always the case. And people interpret that information based on what they already know, what they already believe. And so it's not a straightforward kind of situation, unfortunately. So in terms of the main considerations for acceptance and attitudes in the context of risk, the main one is that synthetic biology essentially redefines our understanding of biology and nature. So, people, or lay public, have this real conflict between, how can something be biological but then it's also synthetic at the same time? How can something be natural but it's made up of engineered parts that you can just kind of stitch together and make something new? So it challenges the norm, and it challenges how we've been taught to understand certain things. There's also concern around public access and ownership of the technology. So particularly in Australia, synthetic biology is largely publicly funded. Sure, it's in collaboration, but it still comes from the taxpayer at some point. And so there is that expectation socially that people have a right to have an opinion on something so novel. And the other issue is public access. So some of the technologies being developed, will everybody get access to them? Will it only be those countries or communities who can afford the benefits? And will it make an equal society, or will it further divide different subpopulations? The ability to shape science through public dialogue and engagement is something that's come up in our research, and that's really referring to the public wanting a say in not just how the research
is developed in terms of, what might be the solutions on the table, but also when it comes to implementation, they want to be involved on the ground, if it's in their communities, to be able to participate. And I'll talk a bit more about that in the context of Carp BIOCONTROL a bit later. And then, of course, regulatory consideration. So, for this technology to progress, sure, there are regulatory issues, but what does that mean for the person at home? And what are the checks and balances that this technology must go through, whatever it might be? In synthetic biology, the acceptance of synbio research tends to be dependent on what the end goal is. So health and conservation applications, for example, tend to be a lot more acceptable than other types of applications. Emotions, as I mentioned earlier, they also play a big role, and that's because we have positive association with positive emotions when we interpret information, and probably less positive if we're anxious or we're a bit fearful of the technology. And that kind of relates to the messaging and framing as well of information you provide people on a technology, particularly under conditions of low knowledge. So an example of that is here. It's a classic psych study where you manipulate the messaging of a particular event or technology. So this is about nuclear power. And so the first example, A, says that information frames the message in that the benefit is high. So it could be saying that, nuclear energy is the most efficient type of energy available, there's hardly any waste, whatever. And so if people don't know much about it, they're more likely to infer a low risk given all the benefits that are provided. But in contrast, if you look at example C, the information might be framed as having very low benefit. So there might be risks of accidents, the waste storage is difficult, there might be radiation exposure. If that type of framing is presented and people don't know much about it, in that example, the risk inferred could be quite high. So you can really manipulate what people might think about something. Not that that's ethical, and I don't advocate it. So we'll move on a bit to a more specific example. So this is not synthetic biology, but it is the introduction of a novel, virus or an exotic virus into an ecological context. So just to explain the Carp BIOCONTROL, the premise is that the Australian government is proposing the introduction of a carp herpesvirus to kill carp in Australia. Carp are an invasive pest, and they make up about 80% of the biomass in the Murray-Darling Basin waterways. And with carp, people are culturally, socially, and emotionally attached to carp. So it presents a few social issues. So in the project that we're working on, there's a whole lot of ecological risk assessment and epidemiology modelling going on, but my team and I are responsible for the social risk assessment. And so we have been asked to identify the social hazards that might exist, and they're kind of labelled as risk endpoints, but actually they're just public deal breakers for the introduction of that technology. And so what we're really measuring is this social acceptability of risk. So are people willing to take on what they perceive to be a risky event into the ecosystem around where they live? Regulatory approval, though, doesn't necessarily guarantee that the virus will be implemented into waterways to control carp. And that's because the public will have quite a significant role to play in that decision. And that's particularly the case for environmental impacts or novel technologies that kind of challenge the way that things have usually been done. So for carp control, people typically did fishing competitions to remove a whole bunch of fish. There's electrofishing. There's all these other little methods to try and reduce the carp in the waterways, but nothing is really as effective as introducing a virus. So people are a bit scared of what they don't know. And so the key points of contention for this is that given the virus is going to kill a whole bunch of fish at once, who's going to clean it up and how are they going to clean it up? That's the number one issue. I've been given hurry on, sorry. And so there's also issues around the efficacy of the biocontrol agent, and why can't we just use the fish for something else? And so this is just a map of the different themes of risk that we came up with, and this is probably something that is relevant in the context of novel technologies implemented in the Reef, and so that can kind of you can kind of see how different elements of personal interactions and social elements can contribute to risk perception. So I'll just finish up quickly, just to get to my take-home messages about this. Social risk, it's all about perception. Yes, there are other things like economics and infrastructure that are relevant, but ultimately social risk is about perception. The involvement of stakeholders is really important, even if you think that they are not knowledgeable or they don't know what they're talking about, they still have a right to kind of be involved in that dialogue. And integrating social science with biophysical science can really go a long way in helping the implementation of novel technologies.